Hi guys, we're going to take a look at section 4.1 factors and prime factorization. Just talking through some of these vocabulary words. There's one that I want to add in up here, and that is a factor. A factor could be thrown right in that area there. A factor is anything that goes into a given value evenly. So any number that divides evenly into a given value. For example, let's pick a different color here. How about this? If I have the number 12, my factors of 12 are 1 and 12, 2 and 6, 3 and 4. These are the numbers that evenly divide into 12 without giving me a decimal or remainder. Now, prime number, there's two different types of numbers. There's prime numbers and composite numbers. Prime numbers are any number that can be divisible by 1, we'll just abbreviate, divisible by 1 and itself. Meaning the only things that you can divide that number by without getting a decimal are 1 and itself. For example, the number 3. The only things that go into 3 are 1 and 3. The number 17. Nothing goes into 17 other than 1 and 17. And there's a, we'll do that in a moment. Next, we have composite numbers, and that's the opposite of a prime number. These are numbers that have factors other than 1 in themselves. So numbers with, I'm going to abbreviate again, factors other than, or in addition to, other than, in addition to, 1 and themselves. So for instance here, we looked at the number 12. 12 is a composite number because there's a lot of factors that go into it beyond just 1 in itself. 2, 3, 4, 6 also divide evenly into 12 without giving me any remainders. Now what I wanted to say before is that there's two special things here. The number 1 is neither prime nor composite. Okay, so that one doesn't really fall into either category. The other rule that's interesting is that 2 is the only even prime number, because every even number beyond 2 is divisible by 2 as well. So that makes it composite. So these are two rules. 1 is neither prime nor composite, P or composite. And then the number 2 is the only even prime number. Okay, we are going to be looking at writing out prime factorizations because that's going to help us with what we do later in this chapter. And prime factorization, I'm not going to write it out here, but it is merely the product of prime factors. So it's when you take a number and you write it as a product of prime factors. We'll see what that looks like later. The factor tree is the way that we achieve our prime factorization. So we start with a number, we break it into two factors. And then we break that down, and we break that down until we get to the very end where all of our numbers are prime numbers, and we can write it out, the prime factorization. Okay? Monomials are clumps. We're going to look at those on the last page because these all go together real nicely. This is a little bit separate of a concept, so we'll cover that when we get to it. All right, let's take some practice. They want, first of all, the factors of these numbers. So the factors of 24 are 1, 24, 2 and 12, whoa, 3 and 8, 4 and 6. And by doing it this way, we meet in the middle without missing any. Obviously, this is going to be composite. 41, the only factors are 1 and 41, making that the prime number, a prime number, because the only things that go into it are 1 and 41. 51, 1, 51, and 3 and 17. So there's a couple other factors making that composite. 89, the only numbers going into 89 are 1 and 89. That is a prime number. And then 121, we have 1, 121, and 11. 11 times 11 is 121, so that's composite. We're also going to talk in class about some divisibility rules. So that way we aren't using calculators, so you can check with these divisibility rules to see if something else goes into a number rather than dividing long division each time. All right. We're going to skip example 1 mainly because it's the same thing we just did up above here, but you would list the factors. Obviously, if there's more than just 1 in itself, it's composite. If the only thing that divides into the number evenly is 1 and that number, then it's going to be prime. Take a look at the next page. This is where we're going to start doing this prime factorization. Write the prime factorization of 450. So I'm going to break 450 into 2 factors, and I can choose any 2 factors I want. I'm going to do 45 and 10. Neither of these are prime, so I have to go down again. How about 9 and 5? 9 and 5, and then 5 and 2. 9 and 5 could break down. 9 is not prime, but 3 times 3, and those are prime numbers. 5 is prime, 5 is prime, 2 is prime. So now, just following these looks like a Christmas tree, the bulbs on a Christmas tree, we can write our prime factorization, which is writing a number as a product of the prime factors. So we have 2 times 3 times 3 times 5 times 5, and we want it to go in numerical order. So the final answer would be 2 times 3 squared, because there's 2 of them, times 5 squared, because there's 2 of those. And you can check it by multiplying all these together, and you should get 450 back. Okay, example you try is trying the same thing. And example 3 actually goes over the same concept again. Tell whether the number is prime or composite. If it is composite, write its prime factorization. So let's try one of these. We'll do 32. This is going to be a composite number because I know that it's even, so other values go into it. So I'm going to break it into 4 and 8. 4 can break down into 2 and 2. 8 can break down into 2 and 4. And then 4 can break down into 2 and 2. So we find that we have 32 is the same as 2 to the 5th. That's our prime factorization, and it's a composite number. Okay, let's take a look at the last page, and this talks about the monomials. Went to the same page. There we go. Monomials. So to factor a monomial, write the monomial as a product of prime numbers and variables with exponents of 1. A monomial is a number, a letter, or a combination of numbers and letters. The key here is that there can be only, or rather, we'll say no addition or subtraction signs. Meaning it's like a big clump, like 3x is a monomial, y is a monomial, 4 is a monomial, 4xy squared is a monomial. These are all clumps. Later this year we'll talk about binomials, trinomials, and polynomials, but for right now let's just focus on one clump, okay, the monomial. And these are actually really easy. It says to factor a monomial, write the monomial as a product of prime numbers in variables with exponents of 1. So what you're going to do is you take your value, 6, and we're going to write it as the prime factors, 2 times 3. And then they want our exponents to have values of 1. So it's going to be 2 times 3 times a times b. 15, it's going to be 3 times 5, and that's already broken down into the prime factorization. So 3 times 5 times n times n times n. So with variables, you have to spread them out because we want exponents of 1. With numbers, like we saw on the page before, you can square them and cube them. For letter C, it's going to be 3 times x times x times x times y times y. And that's all you do. All right, I'm going to skip through these ones and go down to the last example. It says there are 36 desks in a large classroom that need to be arranged in rows with the same number of desks in each row. If there are to be no more than 9 desks in a row, how many arrangements are possible? So you take 36 and you just list the factors of it. 1 in 36, 2 in 18, 3, 12, 4, 9, and then you have 6 and 6 in the middle. So from here you could make your arrangements and figure out what your possibilities are if you need to have no more than 9 desks in a row. So you would list them out and then choose which one would fit that criteria.